Give me a second here to get everything queued up. For anyone watching right now, can you hear me okay? Is the volume all right? Am I muted? Turn it up. Cool. All right. Yes, thank you, God of Ducks. Big shout out. Okay. So welcome to second block college algebra. I sent out the notes in an email this morning, just a blank note. So if you're, I don't know, you can write on that on your laptop or just write on paper or I don't know, whatever your plan is to do this. Who knows? This is all kind of brand new for everybody, but we'll see how it goes. So I'm seeing right now, Aiden, this is the second block college algebra. So if you want to come back for the fourth block college algebra later at 11:30, then that would be good to go. Or if you just love college algebra so much, you want to be here for all of it, that's also great. No problem. But otherwise, let's just kick this thing off. Okay, so when I left you guys last week, we kind of talked about our conic section stuff, and we were talking a lot about putting things into standard form from general form. Okay, so just a brief reminder of that to start off for this warm-up. So I have this general form conic section, and first step that we typically know is we want to take our constant and just go ahead and move it to the other side. And at the same time, I'm going to go ahead and group the different variables together on the left side as well. So I'm going to put my x stuff together, I'm going to put my y stuff together, and go from there. So -4x squared plus 16x plus 9y squared plus 18y equals 43. All right, easy enough. I know my goal eventually is going to be to complete the square for both. So before I do that, though, the thing that people have been messing up on and kind of tripping up on is in the cases where there are these coefficients in front of the quadratic terms, in front of the x squared, in front of the y squared, then before we do the completing the square, we need to factor that stuff out. So I'm going to go ahead and do that. Since that 4 is a -4, I'm going to factor out -4, not just 4. So that would turn into x squared minus 4x. And now I'm going to leave some space here because I know I need to complete the square. For my y's and my y squared, I'm going to factor out a 9. So y squared plus 2y. And again, I'll leave myself some space for the completing the square part. Good to go. So just always make sure to check if you see that there is some sort of coefficient in front of the x squared, in front of the y squared, factor that out first, then start going through your completing the square portion. Okay. So for completing the square, brief reminder. B over 2a, I guess in this case, just the b over 2 squared since we factored out. So just b over 2 squared. So -4 over 2, -2, -2 squared, 4. So plus 4. Then for the y's, 2 divided by 2, 1, 1 squared, 1. So plus 1 in there. Now the big secondary part where people tend to go wrong is you guys have been pretty good about knowing that when we add something to the left side, we then need to add it to the right side as well. However, since we factored out these coefficients, it's going to change it a bit because on the left side, we're not actually just adding 4. We are adding 4 times -4. We have to imagine if we distributed that -4, it's getting multiplied by the 4. So on the right, I'm actually going to add -4 times 4. Same thing with the y's. So we're not just adding 1, we're adding 9 times 1. So on the right, I'm going to add 9 times 1. I, of course, know what 9 times 1 is. I know you guys don't, but I'll go ahead and write it just to show that's what we're doing on both sides. Great. So now on the left, since I've created this trinomial that should be a perfect square now, since we completed the square, then I'll go ahead and factor that. X squared minus 4x plus 4. So that would factor into x minus 2 squared. Y squared plus 2y plus 1 factors into y plus 1 squared. Right, and then on the right side, it's just actually doing the calculations. So we'd have 43 minus 16 plus 9, aka 36. For anybody that's ever watching, just, I know it's kind of hard to type out a question in chat, but if you just like drop me a word like wait or hold on or something, and then I'll know to pause while you can type out a question. So just let me know, send me some sort of alert or word. All right. So I'm almost to where I need to be. My issue now is that on this right side I have 36, but I want this to be a 1. So how can I change 36 into 1? We're just going to go ahead and divide the entire equation by 36. So every single term gets divided by 36. Then it's just a matter of simplifying. -4 over 36. That would simplify into -1 over 9. Nine over 36 simplify into 1 over 4. And 36 over 36 is 1. Another kind of key part here is that there's the negative out in front. So I know that whenever I see a conic section that has some sort of negative in either of the terms, either the x squared or the y squared, then this isn't just a circle. It's not just an ellipse. It's not a parabola because I have x squareds and y squareds. So when I see that minus sign somewhere, that's alerting me that this is a hyperbola. Okay, that last conic section that we talked about. So my very last move, just to make things a little bit prettier, is just going to be to reorder it, because typically we like to have the minus sign in the middle of the equation. So I'm going to change this into y plus 1 squared over 4. X minus 2 squared over 9 equals 1. Oops, not a plus sign, minus sign. Boom. So there's my standard form. And the question said also classify. That's what we just did a second ago. I know by seeing that minus sign that that's going to be a hyperbola. And again, just feel free at any point just to slow me down, say, hey, wait, or stop, or something. If you need time to type out a question or ask what's going on, no problem. Okay. But otherwise, I will go ahead and move forward. Okay, so we're going to go on into talking about systems of equations. So we're going to do a lot of different stuff with systems of equations. And some of it will be very familiar. Most of what we'll do today is stuff that you have done before. I know I say that all the time and you hate it, but it's stuff you have done before, in even going back to Algebra 1A. Okay, that's when we probably first started solving systems of equations, especially with these two methods we're about to talk about. But then we're going to go ahead and crank that up, do some new stuff with it that you've probably never done before, and hopefully figure out some easier ways to solve them in the end. Okay, so first option, solving a system of equations by substitution. Solving by substitution is probably one of the first ways we learn, but the steps are this. We isolate one of the variables. And secondly, we substitute, hence substitution, into the other equation. The easiest way to remember to do substitution is if we start with a system and we see that one of them is just a variable that has no coefficient on it besides 1 or -1. That typically is a good alert to say, hey, we should just use substitution here. We used substitution earlier in the semester, or earlier in the year, whenever we did our mixing problems about like this percent acid mixed with this percent acid, or whatever it was. That was solving by substitution. So same thing here, just a brief reminder. So I'm going to take this equation and rearrange it. So first I'm going to add y to both sides to move the y over to the left, and then subtract 20 from both sides to get 4x minus 20 equals y. Great. So I now have y equals this mess. Yeah, not mess, not that bad. 4x minus 20. So I see that I have a y right here. So instead of y, I'm going to go through, take that equation, and substitute in the 4x minus 20. So negative 2x minus 2, but instead of y, I'm using my 4x minus 20. Equals 10. From here, it's just pretty basic solving. All right, we're going to distribute. Don't forget to distribute the entire -2, not just the 2 itself. So negative 2x minus 8x, -2 times -20 plus 40 equals 10. Negative 2x minus 8x, negative 10x. Subtract 40 from both sides. Negative 10x equals negative 30. And then divide both sides by negative 10. So I get x equals 3. A pretty common issue is that when people are solving an equation, whether it's a system like this or a bigger system that we'll do, is we get an answer and then people just stop. So yes, we did get x equals 3, but remember, in order to solve this system, we need to solve for x and solve for y. We need both in order to completely know what our actual full solution is. So we're not just gonna stop there. Now it's a good start. You know, you can circle it or something to let yourself know, hey, that is one part of my answer. But then from there, let's look at figuring out how to get y. Luckily, we already have an equation for y. All right, this equation right here is already y equals 4x minus 20. Well, I know what x is, so let's just take x and plug that in. So y equals 4 times x, but we know that x should be 3 minus 20. So 12 minus 20, I think, is negative 8. No promises. So this is the other part of my answer. Rather than just leaving it like x equals and y equals, I will always want us to go ahead and actually write that as a coordinate. So my actual final answer is the coordinate, the point 3, negative 8. Not just x equals 3, y equals negative 8. It's pretty similar, but it's one of those stupid things that I like to be annoying about. Any questions or want to go back to a step, just let me know. Give me a quick halt. But that's a reminder of what substitution is. You're going to have ask Max for a pencil. I think he's the one that has them all. Check his backpack. Search his backpack. Okay. Solving by elimination. I do. I'm positive Max is watching right now. You know, I don't see his name in the chat, but I'm pretty sure he's here. The kid loves math. We couldn't stop him from being here. See? He's watching for sure. I'm sure his dad has him handcuffed to his laptop. All right. Okay, solving by elimination. So the other tried and true method, elimination, because unfortunately, equations aren't always as simple as just having an x by itself or a y by itself in one of them with no coefficient. So here's what we'll do. So I guess this is for systems of 2 equations specifically, and we'll talk about having more equations later, so get ready for the fun. So we're going to have to, our goal is to get a positive and a negative version of some coefficient that when we add the equations together, one of those equations will get eliminated. So we'll start off by maybe multiplying one or both equations by some constant factor, you know, multiply by 3, multiply by negative 2, whatever. So that we can get the same coefficient but different sign. So again, one positive, one negative. On the same variable. So this sounds very wordy and weird written out like this and doesn't make much sense, but it makes more sense when you see it. Okay. Once we do that, if we need to do that, sometimes that first step isn't necessary, but a lot of times it is, for us at least. We're not in our Algebra 1 days anymore. Then we'll add the equations together. So that variable, one of the variables, gets eliminated. And again, that's kind of the whole point. That's why we call it elimination. It's similar to substitution where after we do our steps, suddenly we have equations that just has one variable in it instead of the two variables. So for example, for this system, 13x minus 2y equals 25, negative 4x minus 3y equals 14. It's not a very good candidate for substitution because I'm looking here and I see that I have coefficients, 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 coefficients. None of these coefficients are just 1 or negative 1. So I'm not in a great spot to do substitution. So I'll instead rely on my elimination abilities. You can choose which variable you want to eliminate. It does not matter which one. It will eventually work out either way. However, every problem will typically have one way that is easier. It's an easier variable to choose. I would say the best way in this case is just to figure out which one will give you smaller numbers, so you don't have to worry about dealing with, super huge, dumb, weird numbers. We'll try to keep them as small as we can. And things that have common factors or small common factors or multiples, sorry. So I'm going to look at my y terms because I see they have these coefficients of negative 2 and a coefficient of negative 3. I like that a lot because I know that 2 and 3 both go into 6, so I can aim my goal number to make both of those coefficients can be 6, and that won't be too hard. Multiply by 3, multiply by 2. However, if I do 13 and 4, then it's going to be a lot messier. My least common multiple would be just 13 times 4. So again, larger numbers, right? Farm the wise. No, thank you. So I'm going to choose to eliminate the y's in this case. So again, my goal is to get 6 and negative 6 for my coefficients of y. So right now I have negative 2. So I'm going to go ahead and multiply this entire equation by 3. All right, so I'm just thinking about, all right, I'm distributing this everywhere. 3 times 13x, 39x. 3 times negative 2y, negative 6y. 3 times 25, 75. Now, for the second equation, I'm trying to get, again, I'm aiming for 6. So I would think 2 here, but remember, we want 1 to be positive, we want 1 to be negative. I already have a negative 6, so my goal now is to get a positive 6. So I'm going to make this negative 2 that I multiply through. So again, distribute. So that would give me positive 8x, positive 6y, and negative 28. Oh, this was a mistake. Okay. So I have exactly what I was looking for so far. I have a negative 6 and a positive 6 on the same variable. Once I have that, then we can just go through, add my systems together. $39 plus 8, 47x. Negative 6y plus 6y, 0. And 75 minus 28, 47. Two. What does 2 mean? True. Too late. Aha. I see. From here, easy solving. Divide by 47. So we get x equals 1. Great. That's sort of how you would circle that. Not really. Let's try again. X equals 1. So that's part of our answer, not the full thing. Don't just stop there whenever you get a piece of an answer. Have to keep going so that we can get the full spectrum. X, Y, Z, whatever variables they are that we're solving for. We need both. So I still need a Y. So we're going to go back and use one of our original equations to solve for Y. It does not matter which one you choose. Again, just choose one that typically has easier, smaller numbers. It's probably your best bet. So I'm going to go ahead and choose this second equation so I don't have to deal with the 13 or the 25. So negative 4 times x, but we know x is 1, minus 3y equals 14. Doing some intense calculations, negative 4 times 1 is negative 4. Don't ask me how I got that. Add 4 to both sides. Divide by negative 3. So y equals negative 6. There's the other part of my answer. But of course, we want our final answer to be written beautifully as such as a coordinate, a full ordered pair. So we win. Now, again, my hope is these past two problems were super, super easy for you, because this, again, been doing this for a while. Algebra 2, Algebra 1A, Algebra 1B. So nothing wild, nothing new, but just a reminder of the general setup, because we're going to use this foundationally for what we're about to do next. Okay, so let's crank it up. So a bunch of you in the chat just now were like, oh my gosh, 2 equations, so easy. It sucks. Let's do more. We want harder problems. We need more challenges for us, Mr. Abundis, please. You know, need to keep my brain sharp on the quarantines and such. So, all right, I've heard your pleas, and we will go ahead then and do solving systems in 3 variables. Okay, so 3 variables. We're going to use 3 equations to do it. So it's going to be great. Here's going to be the general process that we go through. We're going to start off by picking 2 equations. Any 2 equations. Does not matter which one we choose to start with. If you want to throw a little any in here. And we'll eliminate a variable. Now, typically, there will be, again, easier choices, but sometimes maybe not. Sometimes we just have to make an executive decision. All right, we'll eliminate a variable. We'll do exactly what we did to just get rid of x or get rid of y or get rid of z. Next step, we'll pick 2 different equations. So don't want to pick the same ones, but we can still use one of the equations that we used before, but then just whatever the third one that we hadn't used. And then eliminate that same variable. So if we chose to eliminate x originally, then we want to eliminate x again. Or if we chose to eliminate y, then we want to eliminate y again, et cetera, et cetera. Destroy the y's, maybe. Once we do those first 2 steps, this is the only new part. But once we do these, now we're just right back to where we started in the last question. We now have a system of 2 equations, and we're going to solve that either by choosing elimination, substitution. And then, of course, make sure that we are finding all the variables. Don't just stop at x. Don't just stop at y. We need x, y, z. All right. So here's an example of said system. We have 3 equations. We have 3 variables. And I'm trying to figure out what the heck we should do. My first decision is, what variable do I want to eliminate? So if you look at your x's, look at your x coefficients, look at your y coefficients, look at your z coefficients, and see which one has easier numbers for you to work with, then that's kind of your best bet. In this case, there is a really more obvious choice, which would be to eliminate z first. Now, the reason that we would do that is because that second equation already has z eliminated. I don't even need to do my first step of pick 2 and eliminate. It's already done. Okay. So that helps me a lot. So I'm going to go ahead and put some little asterisks by this because I'm going to use it later. All right, so this is basically my step 1. All right, I didn't have to go through and eliminate a variable because I already had one eliminated, so that was really nice. Okay, so now I'm on to my step 2, which is pick 2 different equations. All right, so I'm going to use my other 2 equations, the first equation, the third equation, so that I can eliminate the z for those. All right. So also, if you like to, I typically kind of like to number these just so I can keep track. So first equation, third equation. I'm just going to rewrite those again down here. Didn't change them at all, just exactly rewrote them how they were. I want to eliminate z, so I need coefficients that are the same coefficient, just one's positive, one's negative. For z specifically, I don't care about what the x coefficients are. I don't care about what the y coefficients are. So right now my coefficients are -2 and -1. All right, that's not too bad. So I'm going to aim for -2 and +2. So I'm going to take this third equation and multiply it by 2, but not just 2. I'm going to multiply it by -2, right? Because the -2 times the -1z will create the +2z, which is exactly what I want. -2 times -4, so that's 8x. -2 times y, -2y. -2 times -z plus 2z. -2 times 12, -24. And then the first equation, I don't need to change at all. Let's do x minus y minus 2z equals -6. So second equation multiplied by -2. Again, I chose -2 so that I could get +2, -2. That's what I want, same coefficient but different sign. First equation, I didn't need to change it all this time. Sometimes we will, but in this case, didn't need to at all. So like before, once we have those matching coefficients, now we'll just add the equations together. So I'm just going to go column by column. X plus 8x, 9x. negative y minus 2y, negative 3y, negative 2z plus 2z, 0, negative 6 plus negative 24, negative 30. And now I've eliminated z. I'm going to put another set of asterisks here so that I remember, hey, this thing's important. I need to use this. Okay, so I'll pause for a couple seconds here just to make sure we can all catch up, and let me know if you have any question. Okay, all good? Okay. So I'm going to use this now. My two equations that I had the asterisks by, I'm going to rewrite those down here. So the 3x plus 2y equals negative 25. 9x minus 3y equals negative 30. And I just need to figure out which one do I get rid of now. Do I want to get rid of the x's? Do I want to get rid of the y's? Because now I just have a 2x2 system. Two equations, two variables. This is exactly like that first example we did of elimination. Typically here, well, the easiest one to do would be to get rid of the x's because I'm looking at 3 and 9, and I know that 9 is a multiple of 3. So I wouldn't need to actually do anything to the second equation. I can get by with just changing my first equation. However, if we wanted to do the y's, you could. Okay, we have 2 and negative 3, so 2 and negative 3 both going to 6. So kind of like our first example, our goal would be to make them 6 and negative 6. That would be fine. But let's do it slightly differently. It's just our easier choice. So I'm going to take my first equation, multiply by negative 3. That way I'll have a negative 9, positive 9. So negative 9x minus 6y equals 75. This second equation, I don't need to make any changes to. 9x minus 3y equals negative 30. And then I add them together. All right, luckily we got that negative 9x and the positive 9x. That was our goal. That's what we're trying to do. So whenever I add them together, it'll get eliminated. So negative 9x plus 9x, 0. Negative 6y minus 3y. Negative 9y. 75 minus 30. 45. Divide both sides by negative 9. So we get y equals negative 5. That's a good first part. But now I need to go back. I need to do the rest of my solving. I need to solve for x. I need to solve for z. So I'm going to look at one of my red equations over here. I can choose either one of these, and I'm going to plug in negative 5 to figure out what x should be. As usual, it doesn't matter which one. I will just use the first equation. So 3x plus 2 times y, but we know y is negative 5. Equals negative 25. Do some simplifying. Somebody asked Max what 2 times negative 5 is. I don't know. Add 10 to both sides. 3x equals negative 15. And divide by 3. X also equals negative 5. Okay. So x is negative 5. Y is negative 5. Great. Now, we're still not done. This is a 3-variable system. So not only are we solving for x, solving for y, we're also solving for z. So now we have to go back to the beginning to one of our very first equations, that original 1, 2, 3 that I wrote down there. And plug in our x value and our y value. That way we can figure out what z should be. And again, does not actually matter which equation we choose. Just look for the easiest one. Now, we definitely don't want to pick the second equation, though, in this case, because the second equation doesn't even have a z in it. So there would be no way for us to solve z. All right, so I'm going to either pick the first or the third. I'll go ahead and pick the third just because the third is only a minus z instead of minus 2z. So I don't know. It'll save me a step of not multiplying at the end, I guess. Okay. So negative 4x plus y minus z. Negative 4x, but x we know is negative 5. Plus, I already forgot what I said. No, minus y. Wait, what am I doing? Oh, it is plus. Okay, negative 4x plus y, so plus negative 5 equals, not equals. I hate scrolling up and down. Minus z equals 12. Whew, that was tough. Just hold on a sec, Jake. So, some quick calculations. Negative 4 times negative 5 is 20. Plus negative 5, so that's the same thing as saying minus 5 minus z equals 12. (20 minus 5 is 15. Add z to both sides. Subtract 12 from both sides. 15 minus 12 is 3. So I have all 3 pieces that I need now. I have my x, my y, my z. So when we write our end solution, so now we have 3 parts, not just x, y. So we don't just have a typical ordered pair. But we still do write it in a very, very similar way. So this is technically a 3-dimensional point. So we're not just dealing with our normal XY plane. We're talking about a 3-dimensional graph, which is kind of weird to visualize, but it's true. So we'll write our answers in the same way, but instead of just stopping at XY, then we'll go ahead and throw a Z in there as well, but still just comma, Y, comma, Z, parentheses to close it off. And it still represents a point. So this would be negative 5, negative 5, 3. Whenever, well, so on the PFA, now I have no idea what PFAs are going to look like here for the next month or so. We have a staff meeting today in the afternoon, and I assume that they'll tell us some information then, hopefully. But assuming one day you take this PFA in the comforts of your home, probably. These answers it'll give you a system, and it's just you type in the answer. So it's not multiple choice question. It's not check all that apply. It's just you type in an answer. So you're going to type it in exactly like this. That's an arrow. So you'll type in parentheses, -5, comma, -5, comma, 3, parentheses. Right? Don't put any spaces in your answer. Right? Whenever I made these questions on the PFA, there are no spaces. If you put a space in, even if you have all the right numbers, it will count you wrong. So just parentheses, never touch the space key. Type your numbers, put commas between them, put parentheses on the outside, and you'll be fine. Okay. PFAs. PFAs do still exist, and they will still exist. In what capacity, I have no idea, but they are still a very real part of your grade. Right? Not that anyone in this class does PFAs anyways, but for the rest of the kids in the school, they will still do PFAs. So we'll see. Hey, what? You have a question? Yes, God of Ducks. I am sure that you probably do PFAs, maybe, depending on which particular god you are. Nina, that hurt. I know, Nina. But just living life best we can. We'll see. Maybe this will be an opportunity to turn over, a completely new leaf here. That you guys will be number 1 in PFAs from here on out, doing them from home. We'll see. I think most people do, Jacob. But just wish it were a little sooner. A little bit sooner. I have another system here, but I don't want to rush through it. And I wasn't even sure if we'd get through it today anyways. For me, that means never. Yeah, true. So I'll just go ahead and stop here, and we can do this one next time. Wait a minute. My screen's freaking out. Okay. What? So yeah. Thank you guys for tuning in. Hope you continue to. So again, this will just be on our A days. Okay. So Monday, Wednesday, Friday for this week. If you ever don't make it to the stream or whatever, because you're so busy doing all the other stuff that you're able to do right now, like sitting, then go to the YouTube link. If you go to playlists on my YouTube channel, then there's a specific playlist for college algebra second block, college algebra fourth block, analysis, calculus. So if you just go to college algebra second block, it'll have each of these videos set in there. Hopefully I'll be able to, these morning ones that I do, I'll be able to upload around noon-ish. But if not, then in the afternoon sometime. Just whenever it uploads, since I'll be uploading a lot. So it might take some time. So yeah, this has been quite a blast. Any last, is homework going to be handled differently at all? That's a good question. I don't, again, we're having a staff meeting later this afternoon, and hopefully I'll get some more information on what stuff is supposed to specifically look like. I mean, homework doesn't count for anything anyways. So I think it'll basically be, I'll send you assignments that you can do, and like usual, either you do them or you don't. Again, this class doesn't, but you can do it, and then ask me questions about it if you want during my office hour stream in the afternoon, or send me emails about it. But I'm not going to have you like take pictures and send me things for like homework. So, do you know how to add VODs to your Twitch channel? Yes, I do. I'm good. A meeting is a virtual meeting. Our PFA's homework, I don't really know what PFAs will look like still. Homework, I believe there was a homework assignment for this lesson. I think it was just like a couple systems. Yeah, I did. Well, we're going to still continue, so I wouldn't expect you to completely finish that. The first couple questions are just basic 2x2 systems, and then the questions get into 3 variable systems. So I don't know. We still have only done one example of the 3 variable systems. So if you feel comfortable enough to then go do the other practice problems, that's fine. Otherwise, that's okay too, because we still need to do this example and talk about one of these, or one or both of these examples as well. So you could do those first ones just for general practice of reminding yourself. Again, I know you don't have anything better to do, but if you're not comfortable with the 3 equation systems to do them, then that's fine. We're still going to talk about it more on Wednesday, and then we'll be able to figure it out fully. That's a good question, Nina. I'm not entirely sure. We'll have to see. I'm sure Max will be in the background of Dr. Stanley's webcam doing whatever Max does, and no one can stop him. We expected to get up at a certain time. Yeah, we're required to hold or be available from certain times of the day. I don't remember what that time is because I'm just doing my streaming schedule. So I know that it covers when I'm supposed to be available anyways. So that's fine. But there's like a 2-hour block in the morning and a 2-hour block in the afternoon, I think, where teachers are supposed to be available, or like holding office hour type things, at least, be checking their email or whatever. I don't know what other teachers are doing, to be honest. They could be, I don't know if they're doing classes on Schoology or Zoom conferences, or just sending out stuff to have you guys work on project work. I have no idea. I'm just trying to get my Twitch Prime subs, Can't Stanley stop him. I don't know that anybody can stop Max. All right, at least nobody on this planet. Okay. All right. Any final questions before I go ahead and stop here, since we're done? Looks like, looking at the analysis here, looks like we have over 9,000 viewers. So that's pretty good. Hoping to hit 10K for the first first stream, but I guess 9,000 is pretty good too. We're just trying to climb here. Spring break, super fun. Do I really want that many people staring at me? Of course. You guys know how much I love attention, right? I tell you, that's why I became a teacher. It forces people to stare at me, listen to what I have to say. It's perfect. All right. Well, I'm going to go ahead and get off here for a little bit until my 20 minutes before my calculus stream starts up. So feel free to email me with any questions you guys have. Or again, at least the schedule might change. I don't know. I'm just kind of test running what this is like. But every day, office hours, just 1:45 to 2:30. So if you have questions, feel free to pop in there and ask, or just email me. I'll try to get back to you whenever I can. But yeah, otherwise, I'll see you guys on Wednesday. Hope you have fun doing your virtual classes. This is our life now. 2020, we're really doing it. So, and hopefully after today, I and every teacher will have more information for you as to what in the world is actually going on and what's going to happen here, because I'm not 100% sure. But regardless, I will continue sitting here and talking about math because it's better than sitting here and staring at my phone. So I miss you guys so much. All right. I will see you guys on Wednesday. All right. Have a good day. Peace.